So, as I said, it's a package of packages which allows you to read, write, clean, merge, and plot everything very easily in R. That here package makes using relative file paths easier, but you don't really need to use that for this now. If you need to download the data, you can follow that link to GitHub as well. That's just following back to my repository, and just remember to look in the correct subfolder to load in that reaction time data. Here's just some instructions that I followed through before, so I'm just going to leave this for now, okay? So now you've got the data downloaded on your computer, you need to upload it into RStudio. So you need to use this upload button in your file path. So you do that by going to Files, clicking Upload, and selecting your data. So let's do that now. So I go to Upload, I browse to my files, it's in my downloads here. So I go here, Intro to R, Data, LexDeck Raw, Open. So if I click OK, this is now going to be loaded into my basically my file pool here, but it's not accessible to R right now. So what I need to do to load my data, so I call this load data, is, I can't remember the name that we're going to use for it, LexDeck data, very simple, LexDeck data, and I use this assignment operator here. Now what this means is says set this variable to something. So we'll use read CSV, and we'll read in lexdeckraw.csv. So this needs to be in quotes and it has to have that CSV extension. So lexdeckraw.csv. Now the reason we're using CSV files is they're not really tied down to any sort of program. So it's a nice way for you to share data. That means that you'll always have access to it in the future. So I'll click play, and you see it has this information. It was parsed with column specification. So what it does is it takes those columns, these become headers, subject and trial native language, and it tells you, well, this one's a character, this one is a number, so it's double. And basically anything with a string becomes a character essentially, but you can define how it behaves if you want to get advanced here. So I'll save this. You'll see that this popped up in my global environment, so I know basically what the data looks like. Now if I type this here, LexDeck data, then this is what my data looks like. Now by default, a tibble, which is a way of presenting a data frame in R, which is defaulted from using this read CSV function, defaults to not showing you every single row, so it doesn't flood your console when you type the name of the data. Now you can see that it gives you the definition that what the data types are for each variable here, for each column. But if you're maybe using just a traditional data frame, which is a way for storing separate types of data just like this, so you can have characters together with numbers in separate columns, then what you might want to do is type head LexDeck data, and it just gives you the first 6 rows. So you know that way you're not going to flood your console or crash anything. Now, I've already explained how the assignment operator and everything works here and how read CSV works, so we'll move over some basic functions in R. Now I've seen how to assign things to variables already, and that it pops up in our kind of working our file list there on the side. But these variables can be anything. They can be numbers, they can be strings or lists, matrices, or even data frames, which is what we have right now. Now data frames are a very useful way for storing data in R because they allow you to put everything together in a table. So you have access to, say, demographics or information about the conditions people were in, as well as the scores they got on maybe a certain test. Now, the nice thing as well about R is that it's a vectorized language. So if I perform an operation on a column, it'll do it to every number in that column in R. So it's really nice for basically just applying the same function over very many numbers. You don't need to write loops for everything. Now you can perform a lot of logical operations in R, so you can in other languages, and lots of basic mathematical operations as well. So for example, x is less than y, or x is equal to y with those double equal sign, or x is not equal to y, and we'll see whether that's true or false. You can just add numbers together, divide them, or multiply them as well. Now it also has some nice default functions from the stats package, which is mean, standard deviation, and length as well. So you can work with lots of these good functions here to save your time. Now by default, as I said, the tidyverse functions assign your data to a variable as though it's a tibble. So it's a table of data, but the nice thing is unlike a data frame, which is traditionally how things are read into an R, it's a little bit stricter on how the data types are kept. So if I try and drag out an individual column from here, it'll still keep it as a character rather than, or keep it as a tibble rather than trying to assign it to just a simple character vector instead. But we can look at our data by using glimpse, which basically is very similar to head. So I might actually just cycle up to my old command by pressing the up button on my keyboard and change that head to glimpse. And this allows me to see my data in another format. So maybe if I've got loads of columns, it's better to look at it this way because it just gives you the first few observations. So it's just a transpose print. So then data frames and tibbles are basically just made up with several different variables. They're essentially the same thing, so you don't need to know too much about the difference about them. But we can access individual columns here by using dollar notation. So let's say I want to figure out what's the grand mean for reaction time. Well, I take my data and I access the column RT, reaction time, using the dollar notation here. And now I've got that data, that reaction time data, I apply the function mean to it. Now I've passed an additional command here to the NARM, and I've given it the argument true. So what I've basically said is make sure you remove any missing values before you calculate the reaction time. Otherwise this will fail, because as soon as it encounters one missing value, it realizes it can't calculate a mean on a missing value. So it's nice for being quite strict here. So we'll do this. We'll do mean, lexdec data, and we'll do rt na.rm equals true. I can take that code and actually put it in a chunk as well, so that probably would have been better for me to write in this. So let's make grand mean, that's the name of my chunk. And so I know I can just run this again, and you see you get the output there straight in your report. So I save regularly. So we'll go back here. So first off, what we want to do is we want to make a graph. Okay, so the tidyverse has a package in it called ggplot2, which basically stands for the grammar of graphics. So the idea behind the grammar of graphics is that you're going to build up a plot from very many layers. So first you need to figure out, well, what goes on the x-axis and what goes on the y-axis. So this will just basically make a blank canvas for you. Now once you've done that, you want to decide what goes on the canvas. So you decide, well, I'm going to put a box plot on top of it. If you want to change anything in addition to this by maybe changing the size of the font, for example, on the x or y axes, you add that as additional arguments. So you always have this basic frame of your structure where you call the ggplot function, you say that the data it's given is the name of your variable in R. So here it would be lexdec data. Then you define how the data is mapped onto the graph here. So you say the mapping is made up of an aesthetic. So aesthetics are simply how do things look. So you're saying, well, I want X to be made up of the native language. So we have everybody's native language on the x-axis. And Y is reaction time. So I want the reaction time on that y-axis. Once you close that, if you run this, you know that you just have basically a blank canvas here. But once you add geom_boxplot, you're adding geometric shapes to this plot. And this particular geometric shape is a box plot. So essentially ggplot's very consistent in that it always needs to take some aesthetics and it always needs to take some data. On top of this, you always add geometric objects to it, which is how you're going to display that data essentially. So why don't we make this ggplot call now. So we'll call this our first plot. I'll do ggplot and I'll do data equals lexdec data, aesthetic, x equals native language, and y equals RT. I'll then add to this, or actually I'll show you what that looks like first before I add anything. So this is how this will look. So I've got native language on the bottom, I've got reaction time on the top, on the y-axis, but I don't have anything in the middle. That's because I haven't added any geometric shapes. So let's add geom_boxplot, and we don't give it any additional arguments here. So to give us a bit of a warning, it said it's removed 53 rows containing non-finite values, which means essentially it's removed some missing values here from our data. But that's fine for just showing how this works. So you see, actually, this is really messy data. We've got English in title case, English in uppercase, other in title in all uppercase, and then NA. So that shows us a bit of a problem. So we'll filter out, or we'll change our data. So we want to clean our data. So we want to make everything to lowercase. So how this code works, this is from dplyr. So we're doing a few interesting things here, actually. So I know it's a little bit advanced. So we're assigning our data itself, and then we're using this pipe, which essentially means and then. So this is good for readability because it means you don't need to keep nesting functions on top of one another. So what we can do here is we can take our data and then mutate it. Now, how are we going to mutate it? How are we going to change its look? Well, we're going to make native language from itself, but where every name is set to a lowercase. So this is going to help to solve that problem where we have lots of differences in terms of the case for presentation for things. So let's do this here. So let's fix data. Fix data. So it's lexdec data is lexdec data. And we're going to assign this by using mutate. Native language equals toLower, which is a base function in R, native language. Now once we do this, let's say I want to run this code again and see what's happened to my graph. I can just do this again. Just be mindful though that if you copy your code, you need to rename what the chunks are called. So we'll call this second plot, otherwise it kind of fails. So if I run this, now you'll see we've got English in lowercase, other in lowercase, and then our missing data. So things are a little bit better now, but we still have some of those missing values. So we could have had a look at that by just using this unique value by saying, basically, what are the unique values in lexdec data in the column native language? And it tells us English, other, and NA, but we had it in the other version just there as well. So what we're going to do is we're going to take our data, so after we've made it to that lowercase, we're going to assign it to itself again, but we're going to filter out any reaction times that are, filter it to keep only reaction times that are not missing values, so it is not NA. As well as that, we're going to keep only the native languages where it's English or other. So we want rid of anything that is like NA as your native language. So we want any reaction times that are missing to be gone, and anything where we don't know what your native language is, that's going to be gone as well. So we could have actually built up on this code before. So you can improve this by, again, just going filter, and we're going to have is NA reaction time. So get rid of anything that is missing data. So I'll just format this a little bit better so you can see the different arguments. And then I want native language in, then I'm using concatenate to put my two strings in. So I want English and other. So you can just put additional arguments on a new line here. And this in thing is essentially saying what I want to check is that you're only getting English and other, which is in native language, nothing else. So what I can do is I can run all my code again from the top. I can do run all here, or I can run from the top, and I'll just run everything from scratch again. So I've read my data in, and now you see when I've ran this code to make my new plot, I don't have any missing data anymore, and I've only got English and other as my native languages. So here I've done quite a lot of interesting things. I've changed the format of the data to look a little bit more consistent, and I've got rid of some missing values. So it's really nice now. Now, what's interesting though is that this box plot's shown very many reaction times as outliers. So why is that? Well, having some knowledge about the data is very useful here. So as I said at the start of this lecture, the reaction times are essentially, or the data is essentially shown a trial by trial representation of each person's performance. Now on any individual trial, you can be very variable in how you respond. Let's, for example, imagine you weren't paying attention on a trial. You might take a very long time, to respond to whether or not it's a real English word or not. So generally what people sometimes do to model this data is to make averages of the data. So we'll just make one average per person's reaction time, which should help to cancel out some of this variability in scores. So what we're going to do is we're going to use some functions from dplyr called group by and summarize. Now, group by essentially works by saying, get my data and give it these groups. So we're going to group it by each person. And we're also going to add in native language. So anything you add to group by has to be kept in your summary of the data, because otherwise how can you describe it by those groups? Now once we do this, we're going to use the function summarize, where we'll make reaction time, a column called RT, from the mean of reaction times. Now we want to fit a linear model to our data now, so you might be wondering, why are we averaging the data? Well, remember from the previous lecture, one of the assumptions is that each observation is independent of one another. So for example, you get one observation from one person and that shouldn't affect the observations from another person. Now, if you have individual trials from the same person, that's a problem, because the same person should respond in some similar way to every item than other people who respond to similar items. So if you want to model this entire raw data, you need to be using what's called a multi-level model. But for a simple linear model, we can just average the data instead. So let's make some descriptive statistics, or we'll make the data, saved by subjects. So that's why we're calling it lexdec subj now. So we'll go back to our data here, and I'll just add in some additional stuff below this. I'll make a new code chunk and I'll call it by subjects data. So it's called lexdec subj. It's from my lexdec data, and I'm going to group it by subject and native language. Then I'm going to make a summary, which is summarize, where reaction time is the mean of reaction time. So let's run that, and we can have a look at our lexdec subject data with glimpse. So I'll do this in the console because I don't really need to care about saving this. So lexdec subj. Okay, so now we've got participants 22, 24, 27, A1. So again, it's still a little bit messy. Their native language is other, English, English, and you can see the reaction times are 511, 530. So these are average reaction times across the entire experiment per person. So now this should help to get rid of some of those outliers that we looked at. So let's say I might make our third plot again to see what were the changes that were made. So we'll call this our third plot. Now, of course, you wouldn't do this all one time if you're going to make a report, but it just helps us to understand how things work. And the nice thing is you can reuse your code, just change that lexdec data to subject. So now if we press play, we should see that nicely we've got rid of all these dots as outliers here. So here's our median response time for English, which seems to be a little bit faster than the median response time for other. What we want to know then is this a reliable difference or not? We could also look at the head of the data here. So this is me using square brackets. This might be familiar if you use other programming languages. Essentially, this is select the row in the first number and then comma the column. If you leave this blank after the comma, then it picks every column in the data set. So I said I wanted rows 1 to 4 just so I could fit it in this presentation, and I wanted every column as well. So you see I've got rows 1 to 4 and I've got my 3 columns for my data here. So then let's have a look at our data. Let's have a look at our reaction times, and are they normally distributed? Are we justified in using a linear model? So let's do geom density instead of geom plot. So I could instead keep this as it was before, or instead of geom box plot, I'll just do, oh actually no, I do need to change this. So I'm going to take my code again and I'll make density, I'll call this density plot this time. Or density plot. So now I want to put reaction time as on my x-axis, and instead of geom box plot I use geom density. So there's my output. To me, that looks a little bit skewed, to be honest. So we've got all of our reaction times here. Most people seem to be pretty much between about 600 or so here. And we'll see that there's this hump towards the side, so this is quite a skewed data set. Now this might be a problem, but to be honest, it's probably fine for our use case here. But if I was to analyze this for maybe a report, I'd be a little bit wary about this, and I might use a different transformation. Now why is that? That's because we know that reaction times are often skewed. So people have an upper and lower limit in terms of the reaction times. So what I might do instead is I might log transform my reaction times. I'll get to that in a little bit. So this is just here where I'm going to create a new variable. So mutate isn't just for changing things, it can also create variables from things that you already have in your data set. So instead of doing let's text subject and just making reaction time as the mean of reaction time, I'm going to make the log, well, this should say log mean reaction time. So I'll make the mean of the log of the reaction time here. So I'll just go back to where I'm making my let's text subject data. Instead of just having RT, I'll also put log RT as mean log RT. Now if I run this again, I can have a look at my code and actually change this to basically log RT instead and see what the densities look like. So here's my box plot again. You'll see that we've changed the scale here. It's updated straight away. And I'll have a look at my density and see if that's any better this time around as well. So I think that's done a better job at capturing the data. It's helped to normalize it out a little bit. It's still not perfect, but I'm a bit happier with that now. So yeah, that's a typo here. I'll try and change this in later updates. So then I've already showed you how to make our final plot where we've put our box plot together, and what we might want to do then is we want to save this. We might want to assign it to a name so we can save it using this gg save function externally. So you might want to put this in your report somewhere. So the gg save function works by taking a file name as the first argument. So what do you want to call it? And remember here you need to tell it what the extension is, what file it is that you're going to use. So here we're going to make a PNG file because I think they generally print out figures quite nicely. You can also make PDF or anything else that you want, or get JPEGs, but yeah, that's fine. Now next you need to just tell it what the variable is as well. So what's the name and then what's the variable. So I might go back to my data set here where I made our third plot, and I'm going to just call this log RT box plot, and I'll assign it itself there. So I might make this more readable for your screens by just using some space in here. So this is how that all works. So now if I assign it, you'll notice that this chunk doesn't return the object. So what I'd have to do if I want to show this in my report and keep a copy of it in my global environment, then I just copy the name out and I paste it here. So I don't need to type print or anything like that. You just give the variable name. So if I do this, I've got my graph back and I can now save this somewhere. So let's make a new code chunk where we're going to save it. Or you could even include it in the previous one. I'm just doing this to try and separate everything out for now. So we'll do save plot and we'll use the gg save function and we'll call this log rt box plot .png and we'll take it from log rt box plot. So you see RStudio has some auto completion as well. Browse a little quick there. Now what will happen here is once I save this, it's going to save it to my file list here. So now I've got this image which is accessible to my computer.